Hi there. Thank you for joining my session. Today, we'll be talking about pragmatic security automation and DevSecOps in the cloud. So let me quickly introduce myself. I am Joshua Arvin Lat. People call me Arvs. I am the Chief Technology Officer of Nuworks Interactive Labs. I am also an AWS Machine Learning Hero, and I'm the author of the books Machine Learning with Amazon SageMaker Cookbook and Machine Learning Engineering on AWS. So feel free to check this out on Amazon, especially if you're interested in performing machine learning experiments and deployments in the cloud. For today, our talk will be composed of three parts. The first one would be a quick introduction to the different concepts which we will use throughout the talk. The second part, we'll talk about the different attacks possible depending on the type of system that you're dealing with in the cloud. And lastly, the exciting part, we will talk about a variety of security automation strategies would be useful for you and your career. So let's get started. So let's start with the introduction. So why are we starting with this one? We would like to start with the reality, where a lot of business owners often would deprioritize security and compliance. Because generally, a lot of business owners think that, hey, there's nothing to secure if there's no business. So let's just prioritize the short term and long term financial objectives first. And then, of course, we need to prioritize also the client and customer happiness. And then finally, that's the time they focus on the other things like operational compliance, along with security, governance, and other compliance requirements. So as you can see here in the screen, the priority level for most businesses for security would definitely be low. And you might be surprised because this may not be what you're thinking of. However, again, most companies often have this sort of priority level. That said, a lot of developers and even engineers dealing with the applications and systems hosted in cloud environments are often not trained to handle and mitigate different types of security risk and challenges. For example, if you're a developer working in a company and that developer is working with a team of data scientists and engineers to build and manage ML powered systems, developers may often use libraries such as this one, where if we were to load a model with payload inside it, then there's a big chance that the system would get compromised. So the challenge there is that developers often just focus on the business requirements and they often try to hit the deadlines. So even if there are warnings or security issues like this, again, developers will deprioritize this and focus on getting the application working first. So what if a malicious user decides to upload a model in the internet and the team decides to use that model. So that model, not knowing that there are certain types of attacks which could take advantage of these types of vulnerabilities, that team would fall victim to that sort of exploit where when the application loads the model, the server where the application is running would be compromised, which after a couple of minutes or maybe an hour or so, the entire account would be compromised as well. So again, the challenge right now is that security is often deprioritized, which means that in terms of training, in terms of budget, there's generally no one in the team who would be able to manage the security risk involved when building different types of applications in the cloud. So, if you were the attacker, how would you try to attack that system? Of course, from a builder's point of view, you'll be telling yourself, okay, it's not a good idea to use that library. However, if you were the attacker, you would think of the offensive side of things and you would think of the different strategies on how to compromise the system. So again, the way the defenders think and the way the attackers think are generally different. And it's important for security engineers to be aware of both mindsets. So if you were the attacker, you would have a malicious file, which is in this case maybe a machine learning model, and that malicious file would contain payload, which contains instructions. So when the application loads that file, the application would also be running the commands in that payload. So in this case, the payload instructs the server to connect back to an attacker machine. So that attacker machine is actually a different machine. So the resource affected would connect back to the attacker machine using something like a reverse shell. So again, I'll repeat that part, a reverse shell. So what do I mean by that? So once the reverse shell has been triggered and the attacker machine is connected to the victim machine or resource, the attacker could easily just perform any sort of operations and actions in the victim machine or resource as if it were his or her own machine. So similar to how SSH works, we connect to a machine and then we basically type in the commands that we need to run. So once the attacker is able to compromise certain resources and machines, the attacker can technically do anything. So the attacker can convert that machine into another attacker machine and attack other systems. The attacker could also check if there are valuable resources and, let's say, database records, which could be used to compromise other accounts or even steal money. So again, the goal of the defenders would be to ensure that the system that they're taking care of would not fall victim into these types of attacks. So in the previous slide, we talked about a single move or exploit. And it's basically a single step where a reverse shell was triggered. In reality, this is just one of the different steps involved when dealing with security attacks. And there is something called the cybersecurity attack chain, where the attacker makes use of a variety of different attacks in sequence in order to accomplish what needs to be done from an offensive side of things. So for example, maybe there should be some sort of scanning happening at the start. And then once certain vulnerabilities have been, let's say, verified, then certain services in the application may be exploited. And then once those applications gets exploited, then maybe the next step would be privilege escalation or maybe lateral movement where other resources and other accounts may be checked and used in order to take over the entire cloud account. So once certain resources have been accessed, then again, records and even databases can be downloaded and other sorts of moves can be performed by the attacker. So again, it's not just one step. It's actually a sequence of steps where attackers take advantage of vulnerabilities which can be exploited. So from a defender's point of view and from a defender's standpoint, how could defenders and security engineers prevent these types of attacks? Given that a lot of the company's budget and resources are actually spent on the building part. So let's say that you had 40 hours in a week. The company would allocate maybe 35 to 38 hours of your time to building the systems. And maybe just 1 to 2 hours for other things. So you would tell yourself, hey, isn't that not enough in order for us to check and audit the security aspect? And if you're asking that question, then yes, that's actually the right question to ask because it's true. It's true that the attacks cannot be prevented by just spending 1 hour on reviewing what types of security attacks are possible. So the best move in order for you to save time and help you manage the different competing needs in your company is to use automation to your advantage. And automation helps us speed things up, where instead of us doing things manually, we're able to focus on the work that we need to do manually and have the rest performed automatically. So, what's an example of this? So, for example, we have an automated pipeline. This automated pipeline basically performs a sequence of programmed steps where, let's say, you push in some new code, you push in some new updates. The automated pipeline would run, and let's say in the second step, different sorts of tools and libraries would be used to assess the code. So maybe the different libraries used would be checked. Maybe if there are existing vulnerabilities and weaknesses in the packages that you used, those would be flagged by the second step. The third step may be a manual approval step, where additional checks may be performed by a security engineer, maybe using a set of tools. And those types of checks need to be performed after the second step. So even if the second step has been performed manually, has been performed automatically, the third step can be manual. And then the final step would be the deployment step. So once all checks have been performed, then the application can now be deployed to production. So again, these types of pipelines are helpful, and this is about combining the DevOps CI/CD process with that security component in order to ensure that before we actually deploy the changes in production, we're able to ensure that the system is also secure. In some cases, especially for companies without a security pipeline like this one, teams would be deploying changes to production only to find out that after running vulnerability assessment tests that a certain component in their application is vulnerable. So they would have to roll that back and spend maybe 1 to 2 weeks resolving and remediating those vulnerabilities and then perform the deployment maybe a few days later. So again, that's not the recommended process. One of the best ways would be to incorporate security as early as possible and use automated pipelines in order to reduce the amount of time spent on security checks. So now that we're done talking about certain concepts which are very relevant to the different other slides in this talk, let's now proceed with part two, understanding what attacks are possible. So a lot of us, when we're trying to learn about security automation and DevSecOps, we try to learn the different concepts like DevOps, we try to learn the different automation techniques, and we try to force the usage of these concepts in our everyday lives. We try to copy what other companies are doing, but in reality, what we should be doing is we should try to customize the solution to what our company needs. That's why it's important for us to understand what attacks are possible in our own system. So for example, for this one, this is a system utilizing Kubernetes inside our AWS account. So here, it's easy for us to spot, hey, isn't the Cloud9 EC2 instance high risk? Meaning that given that it's in the public subnet, is it prone to attacks? So yes, it might be true that it might be prone to attacks. But at the same time, a lot of us are unaware that Kubernetes, especially when not configured properly, can also be prone to attacks. So security engineers must be aware that developers and DevOps engineers trying to use Kubernetes might be overwhelmed by the different combination of steps in order to manage that framework or by that tool. So security engineers must be aware that maybe the one deployed in production might be using the security standard defaults, which the impact of that would be that for that setup to be insecure, given that the DevOps team didn't configure the production setup properly. And a lot of teams actually encounter that problem. They would try to use that shiny tool and they would try to include that in their resumes. And then after 1 month, 2 months, their system would be attacked because they forgot to secure the production configuration. So again, tools and services like this can easily be secured as long as we properly perform the steps to secure this. So again, teams forget that crucial step. So let's say that we have the type of system. We have to be aware of the different types of attacks possible on cloud resources as well. So in addition to Kubernetes, as you can see, we're using EKS, Elastic Kubernetes Service, and we're using EC2 instances there. So the different types of attacks and risk involved there would include, let's say, ineffective logging and monitoring. It may include also sensitive data exposure, especially for misconfigured resources. In terms of security misconfiguration, similar to what I said earlier, there might be security misconfigurations in the container orchestration tool itself. And in addition to that, maybe the network security configuration has not been processed well also. And in terms of the inclusion of, let's say, CI/CD pipelines, especially when these accounts have these types of resources as well, a lot of teams forget the security of that also. And then in terms of secret storage, a lot of teams have no idea where to store the security credentials. So for example, they'll ask themselves, oh, the best practice for this one is to put everything in environment variables. So again, there's a debate going around when talking about these types of best practices. But the real best practice here is looking for a solution which would work best even if a malicious actor would try to attack that system. So again, best practices from an engineering end may not really be best practices, especially if proven wrong by real attacks. In addition to the example shared earlier, there are also applications utilizing the serverless mindset where different types of serverless services allow developers and engineers to build applications without managing servers. So, of course, in reality, there's actually a server there, but that's the responsibility of the cloud provider. So, here, we only need to worry about the custom part inside the services. For example, this serverless application makes use of a function as a service such as Lambda, and it utilizes other services like API Gateway and CloudWatch. So in terms of the surface area would be different, and the attacks on serverless applications would be different as well. So given that the team would focus more on the code part, then a big portion of the security of serverless applications would focus more on the code part. So attacks there would focus mainly on code injection, and it may include SQL injection as well. So you might think, hey, isn't SQL injection already old school, something which is an attack from the past? So if a developer trying to utilize serverless applications have no idea about SQL injection, then they might try to simply load the request input and put it directly inside an SQL statement. So the danger there is that developers would think, hey, isn't all of this secure already? There's nothing to worry about when it comes to security because we're utilizing serverless resources. The unfortunate part there is that developers have no idea that serverless applications are also vulnerable. And the security level of these applications and resources depend on the developers implementing the code. So there's also something called denial of wallet attack. So if you're using something like Lambda, then a well-crafted attack would be able to use that Lambda function, that compute resource, and have it running an infinite number of times. So that would mean that instead of that company paying for, let's say, $50 per month, the company would be surprised that they would be paying for, let's say, $1 million. So there are a lot of examples of that happening all around the world. And some examples involve developers making mistakes. However, in some cases, attackers would do this where if they're not able to perform code injection, if they're not able to have some sort of remote code execution, especially on your setup, if they see that they can perform attacks like denial of service and denial of wallet attacks, then they'll do that as well. And in some cases, if you're not aware, there's also broken authentication mechanisms which can be taken advantage of. There are some companies who are not aware that when they use and have credentials in the front end part of a serverless application, then the correct set of steps will allow the attacker to get the credentials and perform privilege escalation, especially if the credentials used are bound to an account which have excessive permissions. So again, the attacks on serverless applications are a bit different, but again, when you're using serverless, it does not mean that your system is automatically secure. How about machine learning applications and systems? So let's say you're using a machine learning service and the input parameters to your service would include, let's say, the model artifacts, some custom code, Docker container images, a bit of configuration, and a bit more. And that machine learning service is supposed to produce a server, a machine learning inference endpoint, which is used to perform predictions and inference. So if you have a machine learning system like that, you should be aware that in addition to the infrastructure attacks, there are also attacks possible when it comes to data privacy and model privacy. So again, even if the infrastructure has been secured properly, it does not mean that you're already protected. A well-crafted input can easily take advantage of the weaknesses in your implementation. And again, this would affect data privacy and model privacy. So these attacks would include membership inference attack, model inversion attack, attribute inference attack, and more. So there, kind of scary, right? So if this is the first time you're hearing about these types of attacks, then you would be surprised that attackers actually know more and they have actually specialized on these types of knowledge. Now let's focus on the third part, the exciting part, security automation strategies. Now that we have a good idea on what we need to do whenever we're dealing with security requirements, let's now focus on the different tips and techniques when dealing with security automation requirements. So the first question we need to ask ourselves is, do we need to automate everything? The answer to this one is whenever it makes sense, whenever we're doing something over and over again, and we're spending a lot of time doing something repetitive, when in fact we could have been doing something more important, then yes, it may be a good idea to automate certain parts of your processes. However, it does not mean that we have to automate everything. Okay? So let's say that you have a team of 5 engineers and they would be automating, let's say, for a certain part of the process and they would be spending, let's say, 1 month to automate that one. You would have to compute the cost associated to automating that part of the process. So, of course, you would need to take into account the salaries of the team members performing that automation work. So again, that includes a bit of financial knowledge because in addition to the salaries, you would have to think about the other expenses of the company. So again, there's a formula there, but as mentioned, make sure that we automate the right stuff. And speaking of automation, the next question here is it a good idea to use automated pipelines, especially when trying to secure the output of the development team? So in most cases, the answer to this one would be a yes. Because instead of your team trying to learn all the types of security attacks, trying to specialize in security while they're learning how to code properly, there might be a better way to do that by incorporating security in the CI/CD pipeline, where after the code has been pushed to production before the application gets deployed, then a lot of security checks would be running before the actual deployment step. So the only risk to this one is that a lot of companies forget that automated pipelines need to be secured also. Because there is something called the poisoned pipeline execution, where an attacker will take advantage of the weaknesses of the CI/CD pipeline. So what happens here is that a well-crafted attack would use commands, and these commands would be run inside that pipeline. So let's say that the code is pushed to a repository, and then maybe the configuration is included there also. What if the configuration has been poisoned by the attacker? So yes, so this may include a sequence of attacks in order to perform that attack, but again, that's one of the dangers when you're using an automated pipeline. So make sure that your pipeline has been secured as well. So how do we do it? We incorporate the principle of least privilege. And when you're dealing with cloud resources, there are generally different types of IAM entities. So for example, one IAM entity would correspond or map to a real human. But there are IAM entities which would map to cloud resources. So instead of your cloud resources being assigned IAM roles and permissions, which are overly permissive, the best move there would be to limit the privileges and permissions there only to what is needed by that resource. So let's say that the attacker